Hello, good morning, good afternoon, good evening, depending on the time and where you're watching this video from. So today we want to talk about something a bit technical, but it is important in the life of different individuals, different countries, especially in my own country, Nigeria, where we are currently talking about electronically conducted elections, electronically assisted, not electronically conducted, but electronically assisted elections, where part of the electoral process involve the use of technology. So we want to bring out some of the considerations and technologies behind transmission or transfer of results from a given device to another storage device in the cloud. So what we want to look at is what do cloud and software architectures and designers take into consideration when they want to design a system that they want to be almost 100% available. So that's why we said resilient and highly available architecture on AWS. AWS is Amazon Web Services, which is one of the companies that produce and host computer machines, computer softwares that help you to capture data and store them, so to enable you to use it anywhere and anytime that you want. So a right that we have here is how not to have glitches during national elections. So we are focusing on letting you understand what cloud engineers and cloud designers take into consideration when they want to design a highly available system that will not have glitches. Okay. Who am I and why should I be talking about something of this nature? My name is Peter Eze, a PhD holder in computer science. And in terms of training and specialization, I am an AWS certified machine learning specialist, which means I design solutions and deploy solutions that relate to the use of machine learning while leveraging AWS technologies. So what will we be talking about today? We will focus on what is called offline first design, which is how do you design an application that works even if there is no network? AWS managed services. What are the services that AWS tell you they will be able to manage? So you pay them to actually manage those services and make them available whenever and wherever you want them. What is auto-scaling and load balancing? We have to talk about them. We talk about shared responsibility model. So what is AWS expecting you to manage? And what is AWS expecting to manage? If you contract them to do something for you, what are your own responsibilities and what are their own responsibilities? Then we talk about sample design. How do cloud engineers put together services and say how much percentage availability will it be, or how much downtime if you look at it in the other way around? So these are the things we want to look into. So here we start with what is called the offline first design. So whenever you're deploying an application in an environment where you know network will not be completely available, such as also in most countries, not just Nigeria, but there are different places and different regions where the strength of the network is not high. So you are not sure that network will always be available. So what engineers do is that they follow the offline first design paradigm. Offline first means assume there is no network first. For you to design this type of network, you have to consider two storage. You have a local storage and you have a network data source. You have a local data source and you have a network data source. Local data source is a space within that computer or BVAS machine or whichever electronic machine you are using to capture that data. So you are not expecting that computer to transmit that data immediately. So you hope, you say even if there is no network, you have made a provision for local storage. So it will be able to store the information in the computer. Then it tries to check when network becomes available. So whenever network becomes available, it now transmits it to the network data source. So let's assume there are different devices. Let's say device 1 and device 2. This could be computer or BVAS machine or your phone. So this device 1 has an application that captures data. It is also supposed to have its own local database. You have another device that is running an application. It is also supposed to have its own local data source. So let's assume all the BVAS machines in all the polling units of the Federation, all of them are supposed to have their own local storage. So they first of all store the data captured locally. Whenever network becomes available, they transmit it to the backend service. So the question is, can this be done using AWS technology? Did AWS provide certain services that you can use to achieve this design on AWS? The answer is yes. Let's assume you have your mobile devices or BVAS machine or whatever. We have different services in AWS called Amplified Data Store. So the Amplified Data Store is what enables you to design an application that considers local storage first. So when there is a local, when you use AWS, you have to consider the Amplify, you have to consider AWS AppSync, and you have to consider Amazon DynamoDB. Now, there is a difference when you are actually supposed to store just a blob. A blob is something like captured image, captured video. So in the case of INEC, what we are storing is a blob. So what do you do in that case? You will still follow this design, but you are now going to, instead of considering just a simple storage engine, you are also going to consider folder. So within the local computer, you are also supposed to design a local storage that can store this blob, which is like image. Now, when you are uploading to the backend, you also have to consider what is called the S3 bucket. The S3 bucket is what AWS uses to store blobs such as images, videos, and text. So in this design, whenever network becomes available, after storing what is called metadata, metadata could be which polling unit are you uploading it to, in which state, in which country. They can be the ones that is stored on the Amazon DynamoDB. But this image captured of the results of the polling unit will now be picked up from this local storage and transmitted to AWS on this S3 bucket. So the BVAS machine will have the capability to do that if the engineers has used this kind of architecture to design an offline first architecture. So the next thing we want to talk about is AWS managed services. Now, before the advent of cloud, people design, say, database, web app, like what you are seeing here is EC2 is cloud compute, that is computer in the cloud. We have relational database, we have a direct connect. So in order not to be too technical, these are the services that enables you to design an application that can capture and store data. Now, AWS is trying to tell you that if you think that you're going to have challenge with creating these systems by yourself and managing it, they are telling you we can do that for you. Assuming you have power outage, you don't have competent engineers, you don't have the resources that will enable you to do this. They are saying, come, we negotiate the price, you pay us, we manage all these things for you. So all these are AWS managed services. Now, it is important to understand what AWS is promising. What are they telling you they can do if you go into agreement with them? So each of these devices that you put together to form an application, they are agreeing to what is called the service level agreement. So they tell you, they assure you that if you allow them to manage your services, that these levels of availability is guaranteed. Now, let us look at this thing I'm saying here in terms of time. AWS is saying if you're paying us for 99.5% availability, your computers and your network, the worst that can happen is that it will be off for maximum of 3 hours, 39 minutes in a month. So that is downtime. Downtime is when it can have glitch, right? Downtime is when it can have glitch. So if you are paying us for 99.5% availability, the worst that can happen, they didn't say it must happen. They said the worst that can happen is that your system could be down for up to 3 hours, 39 minutes, and 8 seconds. If you're paying us for 99.9% availability, we are guaranteeing that the highest that your system can be down is 43 minutes, 49 seconds in a month. If you're paying us for 99.95, the worst that can happen is that your system will be down for 21 minutes, 54 seconds in a month. If you're paying us for 99.999% availability, the worst that can happen is that your system will be down for 26 seconds. This is what AWS is guaranteeing if you are using their managed services. Their managed services move from network to databases to what you use to store your data to the machines you use to store this data. So if you do that, they will be able to I guarantee you this. Now, why am I putting this cost here? The thing is to tell you an example of what it will be costing to do some of these things per month. A dedicated EC2, which is a type of computer, which I've checked online, if you use AWS costing calculator, if you choose dedicated, so for a national assignment like national election, you need to use a dedicated system. You don't need to share this computer with anyone. So it is going to cost about $1,468.32 for one of those computers per month. So you don't run millions of these computers actually because they have high capacity. So I've chosen the ones that has high capacity, very high memory, compute speed, network bandwidth. So this is example I'm using here. So this is like the best you should be able to get. You will not be needing millions or even thousands of these to conduct a national election. Just a couple of tens of these computers. We are going to see example of what you'll be needing when we go to the section on designing a highly available system. So if you think that your country probably have issues and challenges with running your network, and nothing stops you from designing an architecture that relies on AWS managed services. So I'm showing an example here. Let's assume you are designing a system that has several web servers and you're looking for 99.5% availability, what happens is that you will not use just one of, say, this computer. Oftentimes you have to use more than one. And you can see, like in this example, with 90% availability for each of the servers, this 1 to 3 computers, 1 to 3 application servers, and only one database server is giving us 98.8% availability. This is still not up to the 99.5%. But what I'm trying to bring in essence here is that it doesn't mean that you will use one of these computers to achieve the availability you want, but it doesn't also mean that you will need hundreds of these computers as well, actually, to achieve a very high level of availability, looking at the numbers we have here. Again, I would want to say that AWS managed services are mostly zone or geo-redundant. Geo-redundant means that a replica of a copy of whatever you're saving in one machine is being saved in another machine somewhere else, which means whenever one of the machine fails, the network automatically switches to the other one where you're saving a backup. So there is no need for you to start a computer or anything. A part of your agreement with AWS for managed services is automatic failover. Automatic failover is if there is any glitch in one, immediately a glitch is detected, the computer automatically switches itself to another computer in the network and everything continues on. That is what enables them to achieve this level of availability and downtime. Okay, now what is called auto-scaling and load balancing. You find out that normally what is expected is that when one person is using a network, there will not be problem. 2 people, there will not be problem. 10 people, 100 people, or 1 million people. Now, because of the fact that you pay for more machines that you start in AWS, what happens is that you don't start millions or hundreds of computers at once. You start with one. So this is the backend server that stores your information. You start with one. If one person initially, let's say on the day of the election, you start with one computer. And all these things happen automatically. You don't need to do them manually. You start with one computer. As the load continues increasing, more people start logging in and trying to upload information. What auto-scaling does is that depending on the usage of the network, let's say you have configured it that when 10 people are connecting, it should start a new computer. The auto-scaling, which you have configured as part of the design, will automatically do this for you. Now, what a load balancer does is that if more people are connecting, instead of everyone connecting to just one server, the load balancer knows how to distribute people that are connecting to different servers on this network in such a way that no single computer in the network will be overloaded. So you will not have glitch because you have configured it in such a way that when more people are connecting and the network is becoming slow, it automatically starts a new computer. And new people that are connecting to this computer automatically connects to a new type of computer. So there will not be congestion in the network. So, and then this load balancing and the auto scaling still saves cost for you, because even though you have told AWS that you are going to use a 100 system for your election, it doesn't mean that you're going to pay them for these 100 systems upfront. It means that you could use, but in the end, they're only going to charge you for what you actually used. So if you do load testing, you are going to know whether a maximum of 50 computer can take all the polling units that are uploading the result. So of course, you make budget for that, but that doesn't mean you are going to use all that money. What is important as we're talking about here is that we have a feature in AWS that enables you to either scale up or to scale out depending on the number of people connecting to your network. Scaling up is increasing the CPU size, increasing the RAM size. Scaling out is like adding more machines to the network, to the backend server. So this is how auto-scaling and load balancing works. Load balancing is distributing the load to different servers such that there will be no congestion. Auto-scaling means bringing up new computers or increasing the size of existing computers as the network load increases. So irrespective of what is happening, there won't be glitch if you have followed the right design to make your network to be highly available and reliable. So this is an example of like replacing these computers with a set of BVAS machines provided by INEC. Now, let's talk about the shared responsibility model. Let's talk about shared responsibility model. Now, most of what I've explained about AWS is dependent on how you have configured your network. If you decide to give AWS all those responsibilities, then they will bear the responsibility. But if you decide to have a hybrid cloud where some part of the application or network or machines will be taken care of by you, then you are not expecting AWS to share all those responsibilities. So before we determine whether any fault actually came from, say, AWS or INEC or whoever, we have to be aware, or they have to tell us the architecture of their cloud, whether they actually allowed AWS to handle all those responsibilities or whether they have some networks on premises. So there are different situations that we can see here. We can see a situation where a client, an example of a client is like a BVAS machine or computer. First of all, connects to INEC servers, which might be local in the country, Nigeria, and then from there, traffic now moves to AWS cloud. In case of the iRev we are talking about, iRev itself as an application could be on the local network or the data center of INEC, or it could have been hosted in AWS. The application, we know that the actual data was stored in AWS. However, it wasn't clear, at least to me, if the application was hosted on INEC first, which means the first thing you hit is the INEC server, but probably the INEC server uploads the data to AWS. An alternative is hosting both the application and storage on AWS in such a way that what you see is that clients can connect directly to AWS cloud and just keep the information there, which is like the polling unit captured EC8A. These are architectures that are different. So the configuration that happened will determine what is the point of failure. And this is why all servers probably will need to be audited before they are used for official purposes. Everyone needs to understand what is the architecture. And this is not a security threat, really. Understanding on a high level, what is the architecture of a network, be it government network or not, does not breach security. So you don't secure your network by simply saying people should not know how I configured my network. The configuration parameters can be secret, but the architecture of this network can actually be public. So if you cannot proof your system by making your architecture public, it means your network can never be secure. So in the process of ethical hacking, what people do is to expose the network architecture to people who try to hack these networks. But your configurations and your firewalls and your protection should be solid enough to make someone that even knows the architecture of that network not to break through. The subject of this discussion is not actually security, but actually the reliability of your architecture anyway. So what I'm trying to say here is that a government or an organization expose the network architecture does not mean that they are exposing the security of that network. So we need to make it clear. So depending on whatever type of clouds that an organization such as an INEC deploys, you will be able to understand what responsibility lies with that organization to protect their data and network, and what responsibility lies with AWS or any other cloud provider. So I know that this table might be a bit more for non-technical people, but this just use these green colors, this blue and orange color to understand how the responsibility changes depending on the type of agreement you decide to go with AWS. So we say the ones in blue represents the customer responsibility. So maybe in this case, kind of say INEC, and the AWS responsibility is the ones shown in orange. So let's say, for example, if what say INEC decides to do is simply to buy a machine from AWS and say, don't worry, we will configure all the networks security, we will configure all the web servers, we will configure all the databases, then this is the type of responsibility. The AWS is only responsible for protecting that computer and the storage and other hardware and global infrastructure, depending on where you want to deploy your application. However, every other thing like the client-side encryption, server-side encryption, network protection, operating system you use, the platform of the application you decide to deploy is not the responsibility of AWS. So this is also another example of an architecture that increases the responsibility of AWS and decreases the responsibility of the organization. In this last one here, we can see that when we get to managed services, which is the example I've said, a lot of responsibility now goes to AWS. So that's 99.5 or 99.99%. You can expect them within these regions that are orange. So you cannot really say what the client can do in the blue side. However, giving more responsibility to AWS reduces the risk that you bear on your own side as a client. So we know that for managed services that AWS has promised a high level of availability. What we need to ascertain from our government organizations, including INEC, is on the side that they are managing, what level of SLA, what percentage of availability are they promising to the citizens? Of course, the citizens' tax and money are used in conducting of elections. It is also a question that individual citizens and political parties should be asking is, on this side that you're managing, what is the level of competence? What is the guarantee that you're giving us based on your preparation on the funds that we have provided? So as AWS is agreeing to a level of service level agreement, as other organizations of government should also be saying, this is the budget we need to achieve this level of availability for our systems during these elections. So this is the type of discussion that should be going on from now onwards as we go into future elections. Okay, so this is an example. I've mentioned previously what a level of downtime mean and what service level agreement means. If an architect wants to design a system that has to meet these standards, there are simple mathematics that that needs to guide the person. We are not saying that this mathematics here is that once you get this mathematics 99% correct, that everything will work 99% correct. The probability is getting 99% availability, and all things being equal, that is going to be that. And it has often been that, especially in the case of AWS. So you see that if you are designing a system where the web server is only 90% available, the application server is 90% available, and the database server that stores information is 99% available. So when you compute availability, we have what is called parallel connections and series connections. So you see that all these things are connected in series. You get the total availability by multiplying the individual availability. So if you have an electoral system that uses these components to transmit data, you can only be guaranteed 80%, 80.2% availability. This is guaranteed. This thing is not saying that you cannot get 100% within the single day you're conducting that election. It is not saying that you cannot get 100%. It is only telling you that there is a probability that the day that this thing might fail or the hours it might fail might lie within the day you're doing your election. So how do we improve on this? So you improve in your design by redundant design. So instead of using one web server, you are expected to use 3 web servers in parallel. You are doing that because if this web server fails, you can use this second one. If second one fails, you can use third one. Before the third one can fail, you have repaid the first one, and the first one comes back online. So you see how you improve your availability. So using these 3 increases the availability of this web server tier from 90% for individual server to 99.9% because you have combined 3 in parallel. That does not affect the failure of the application server. If the application server is still just 1, the entire system will still be only 90% available. Okay? So what do you do again too? You try to make some of the servers in this application server to be redundant as well, which means instead of providing just 1, you provide 3 in parallel in such a way that if one of them fails, you switch to another one. Okay, so by combining 3, you get 99.9% availability on this application server layer. Then, of course, application server cannot replace database where you store your data. So how many database instances are you going to provide? You provide only 1. Okay, this only one has 99% availability, which we can say it looks good if you can guarantee the 99% availability. Now, this is for individual tiers. After you must have connected elements in the tiers in parallel, you don't have, the only thing is that you have to connect from one tier to the other. So after you do this, you now multiply the availability of the individual tiers. So when you now multiply this availability of the tiers, we now arrive at 98.8% availability. So because of redundancy, we have improved from 80.2% to 98.8%. Now, Depending on how critical this system is, 98.8% might still not be good for what you want. For instance, we saw that in that availability, in that SLA, that 99.5% availability can still lead to 3 hours downtime. So if you don't want, if 3 hours downtime per day for an election is critical, it means that even 98.8% availability is not enough to achieve what you want. Then you have to think about how to improve the availability of this system further. Now, what did we do? What we are doing here is to increase the redundancy of this database server, because this database server is still a single point of failure. If anything happens to this data, a single database server, the entire effort you have put in other layers will be dashed. So what happened here was also to connect more database replicas in parallel, which means as information is being stored on the DB master, the database master, they are being copied to the DB replica. So you copy the information received to this one and copy it also to this one. If this master fails, these application servers can still read from the replicas, right? They can read from the replicas, and reading from the replicas can make your application to continue moving on. And I talked about geo-redundancy as well. If they continue reading, you can now do a failover. A failover can now happen either from this DB master to any of the DB replicas. If it happens, you can now start writing or saving your information to any of the DB replicas. In such a way, the downtime will decrease. And with this final design, we are able to achieve 99.8%, 99.8% availability. So, which means that per month, the downtime for 99.8% is less than 3 hours. So for a whole day of an election, with this type of design into consideration, no matter what happens, you are guaranteed to achieve less than 1 hour of downtime. And this less than 1 hour of downtime must not happen within the election hour. It must not even happen at all. These are all a kind of telling you the probability. So with this type of design, with everything I've explained in this presentation, talking about, so we talked about offline first design. We talked about AWS managed services. We talked about load balancing, and we talked about AWS shared responsibility. If you put these things into consideration in designing a network, be it for a local council, be it for a state government, be it for a national, be it for global, you can use this principle to design networks that will be very available. And of course, all these things go into budget. So for any nation where it was agreed in the beginning that budget was provided for all that is required, it is assumed that the IT engineers, the cloud engineers, the application engineers must have taken all these into consideration in order to come up with the budget for conducting a technology-assisted election in a country. So once again, my name is Dr. Peter Eze, an AWS cloud engineer and a machine learning specialist. Thank you very much for listening. And you can comment, put your comments and your thoughts and your questions or whatever so that we can interact. Thank you.